So we'll start up with the fifth program, which is nothing but clip a line using Cohen-Sutherland's algorithm. That is nothing but, as I told, in this program, we'll be clipping lines with the help of the algorithm which we study. That is Cohen-Sutherland algorithm. Moving on to the algorithm. So I have taken some diagrams here. We studied this kind of diagram, right? So what does the algorithm says? What does Cohen-Sutherland algorithm says? It basically is used for line clipping algorithm. And what does this algorithm does? This algorithm basically divides whatever the dimension 2D or it might be 3D as well in the space. That is nothing but, if I take consider two-dimensional space, it will divide that space into 9 similar regions. That is nothing but 9 particular regions it divides. For that particular 2D space, it is being divided into 9 similar regions. Similarly, we saw how to, that is an unique name given to each region. These are the unique names which are being provided for that particular region. So what does this basically specify? The four numbers, what does it specify? The first number basically specifies the left part of the object, the second right, third bottom, and the last object. Last part is nothing but top of the object. So this is how region code is being generated for that particular space. That is nothing but division of n number, where the n consists of 9 number of parts region here. So as we saw, this is also a clipping part. It's an example of clipping, where clipping is, if I consider this as a window where which should be considered. So this window should be displayed onto the output screen by performing line clipping. What happens when you apply line clipping? Basically this part as well as this part will be eliminated from the particular window. So I have just defined the coordinates for the object which I have been defined here, not object, I can call it as a window, and I have defined what kind of lines these are. I can say this line is completely inside the window, this is partially inside the window, this is out of the region for that particular window, right? That is completely outside the window. I can call this is also partially inside, because the almost 80% part of that line is been inside the window. I can call this also partially inside. So this is an example of Cohen-Sutherland's algorithm, where it is been giving a window after clipping. This is the window which is being displayed once clipping is done. So what does line clipping does? Basically, the output of this program is as follows. I'll just display the output screen. Yeah. So look at the output, students. Suppose this is the input you have given to the system. So this is the object you have drawn. Check out, there are some lines which are partially inside, right? So I want to just display this particular window onto the output screen with the help of a line clipping algorithm, which is Cohen-Sutherland's algorithm. After clipping, this will be your output. So I guess you people have now clear idea. You people got clear idea what does clipping algorithm does. This is a line which is being drawn with respect to that particular window. Once the algorithm is being applied to this, the lines which are outside the region, which are outside the boundary of that particular window, it is being clipped here. So this is the clear object which is being displayed onto the screen once you perform this particular algorithm. So we'll check out how this algorithm works one by one. So we saw this how one of the example and how region code gets generated. Then we'll check out, there are some tests, as we had some tests, right, for finding interior as well as exterior part of a particular object. Similarly, we'll be having some tests for Cohen-Sutherland line clipping algorithm. So we'll check out what is this test. That is nothing but test in the sense you need to remember some kind of operations which are being done while applying or while performing line clipping algorithm. So what we'll do in Cohen-Sutherland line clipping algorithm coding is, there are some operation needs to be performed. The first operation is what is, first we'll do inside and outside test. So we'll check out what is this inside and outside test. When the OR operation between two endpoints region codes for a line segment is false, the line is inside the clipping region. the inside as well as outside test basically tells you where the line basically is applied, where you will get the line, if it is an interior part or the exterior part. Will the line be visible in the interior part, or the line will be displayed in the exterior part? So if you perform OR operations, can someone tell what OR operation does? What is the resultant of basic OR operation? Someone from the class? Someone from the class, tell me what does basic OR operation does?
Additions.
Addition, right? Also, if I give 0 and 1, what you will get the output? You will get the output as 1, right? If I give both the input as same, such as 1 and 1, what will be the output?
1.
Yeah, you will get 1. So that is basically the OR operation. When you perform such kind of operation between two endpoints, here endpoints basically define the points of that particular lines. Okay, when the OR operation between two endpoints for a line segment is false, what does it mean as false? If you get 0, that is nothing but, if I apply 0 and 0, you will get 0, right? If I apply 0 and 1, you will get 1. So in that case, in the first case, in OR operation, there is only one false operation, right? That is 0, 0 and 0, 0, 0, 1, 1, 1, 0, 1, 1, 1, 1 you will get as the output. In the OR operation table, basically you will get only one false condition there. At that time, if the line segment, that is nothing but that OR operations result is false, at that time you should tell that line is lying inside the clipping region. That is nothing but inside whatever you want to clip at that region, that particular the line will be displayed. Then if you apply AND operation, what happens in AND operation? What happens in AND operation? What happens in
Multiplication.
AND operation? Yeah, basically multiplication happens. You need to remember, in OR operation, addition happens. In AND operation, multiplication happens. In multiplication, if you are applying such kind of operation between two endpoints, that is nothing but between 2 points of that particular line, if the resultant is true, that is nothing but not the false value, that is true, then the line is completely outside the clipping region. That is nothing but it comes under the window which you want to display. So these are the two important conditions in Cohen-Sutherland line clipping algorithm program. Basically, OR as well as AND operation is being used, where you'll check the two endpoint region codes for a line segment is false or true. Then you will assume that it will lie inside or outside that particular window. If not this the case, or if doesn't the resultant is out of this boundary, then what happens? Lines that cannot be identified as being inside or outside or checked for intersection with the window border lines. If it is not inside or outside the particular boundary, you will check if that particular line is lying under some intersection part or something else. This is an exception case. Wherever you won't find OR operation as well as AND operation result with respect to that particular line, you will assume that the window is out of the boundary of that particular window where you want to clip the particular object. So these are some of the basic conditions you need to remember while performing Cohen-Sutherland line clipping algorithm. So we'll check out the algorithm. What happens in the algorithm? So this is the theoretical write-up of your program actually. So in the first step, we'll assign a region code for two endpoints for given line. That is nothing but to draw a line in that particular region. You need some two endpoints, right? You'll assume two endpoints and draw a line. Then I will give each of that particular line as one region code. You'll give a unique name for that particular endpoints. If before this second step, you'll be assuming some names for that particular regions. Then if both endpoints, whatever the name you have given for the endpoints, have a region code this, then the given line is completely inside. Then what else happens in this step 3? If this not the case, what happens? you should perform the AND operation for both the endpoints with region code this. Then in there is a sub step in this 3.1. If the resultant is not this, then given line is completely outside. This is the else condition actually. After performing AND operation, if you don't get this as an output of that particular operation, then the whole particular line which is being displayed comes outside the particular boundary, else the line is partially inside. So this is the condition where you need to perform AND operations and you'll check out the resultant. Then after that, if you got the line which comes under the region or outside the region or partially inside or outside, after that you will choose some endpoint of that particular line which is basically outside the given region, then find the intersection point, then replace each point so that you will get that particular window of the displayed output. Then after this, you will be repeating this second so that you will get a clipped object which can be performed simultaneously. That is, once you replace the boundary with some endpoints where you have some intersection point, you'll start on updating this region code. This will be updated simultaneously. This will be looping forever so that this region code will be updated. Then after that, you will start repeating this step 2 until you find a clipped line, either trivially accepted or rejected. What does this trivially accepted or rejected tells? Trivially accepted or rejected in the sense it tells basically what is whatever the line which you have got after clipping, if it lies inside the window or if it lies outside the window or it partially lies inside the window which you are displaying onto the screen. This is what trivially means here. Then you'll start repeating the step 1. This keeps on repeating the algorithm till you get to the clipped object. That is nothing but a clipped object which you want to see as an output. So this is the basic flow of the code which happens there. So we'll check out how the code works. Similar to different all the programs, we have some libraries which needs to be defined. We have a library called glut.h. We perform that in the header file. We include some of the header files called studio.h, and we define some variables with respect to the header file, that is true 1 as well as false 0. What does this mean? As we are using AND as well as OR operations in the program, so you need to define the variables called true false values in the initial step as well. Then you will define bool int which is of type integer. Then comes the variables here. We have two variables x and y. With the help of these two variables, we'll check out what are the intersection points in the program. Then we are defining some of the variables called xmin, xmax, ymin, and ymax of type integer. And I'm assuming some values for these variables. I'm giving some values. For xmin, I gave 50, xmax is 100. Ymin is 50 and ymax is 100. These are some of the variables I am defining here, so that after clipping, whatever I get the value, it should not mess up actually. Why do we use these values is we'll use this for clipping actually. Then I'll define the region codes. I can call these are the region codes. Then I will define some of the variables which are type constant by giving the values to it. As for the right code, it will be 8. This is 8, then left 2, and top 4, and then bottom 1. So these are the values I am giving to this particular region codes. Then I'll define some of the another variables also, outcode 1, 0, out, done, and accept, because I'll be using this in the program. So this is the basically initialization as well as defining step here. Then we'll move on to the main program first, as I'll be telling you in each and every session where the program starts its execution is from the main program. First, we'll check out how the main program works. In every program, the main program will be similar, but whatever the functions you are been using in the program apart from main program, you should include those callback functions in the program here. So I'll start with the main program where I have two arguments called argc as well as argv, which is of type integer as well as character. This is the count and this is the vector I'm initializing for the main program. Then I'll start initializing the library, that is glut library, with two arguments, argc as well as argv. Then I'll check out what is the display mode with the help of this function by specifying some buffer as well as color RGB. Then I will provide position as well as size of the window with respect to 00 as well as sizes 500 as well as 500. That is length as well as width of that particular window. Then I will rename the window as Cohen-Sutherland line and drawing algorithm. So I have renamed this particular window. So once if you just execute the main program, I will get the empty window with respect to the size and position and the name. So this is the main program. Then I have defined init function in the main program. So we'll check out what is the init function. I have defined init function, void init function. I will define the matrix mode. What is the projection type here? What is the primitive? Is GL projection. Then orthograph. I will display the orthographic view here with respect to GLU ortho 2D by giving values to it, parameters to it, and I will define what kind of matrix mode. You are replacing the previous matrix to the model view. That is nothing but whatever the matrix has been initialized in the previous step, it will be in the initial step, it will be transformed to the model view. So this is init function where initialization is in with respect to matrix as well as graphics view where it is orthographic view. Then just a second. Yeah, I defined init function there. Now we'll check out the display function, how the display function works. That is, glut display function works. We'll check out the display function in void display. First, I will set the background color, that is RGB color given, and I will perform alpha value as 1. I have given all the values as 1, 1, 1. That basically tells the background color should be set to what? Which color will be set once I give these values?
White.
Yeah, white. As the output is been already displayed here, so you can check out the background color will be set to white here. Now the background color is white. Now I will clear the buffer bit which is been initialized with GL color buffer bit, and I will give that buffer whatever you want to display onto the screen with the help of GL color 3F, and I'll give the RGB values. That is nothing but I'll set the output value as red here. That is nothing but 1. If I perform this particular operation, I will get the object. After this, whatever the object I will be defining in the output screen, it will be of color red color. Then I will start defining whatever the object I want to. This is basically the display function, that is input you are passing to the program. First, I will start the GL primitive, whatever the object, what kind of object you are drawing onto the screen. It is kind of loop, that is GL line loop. I can call this as a loop light. I cannot give it as just GL line here because this should be in the form of loop. So I'll be defining GL loop here by giving inputs to that particular object, that is nothing but length as well as height of that particular vertices with respect to this. As you have 4 sides for that particular object, it will perform. Once you execute this code, you will get an square onto the output screen. As I told, this vertices function, whatever the vertices parameter should be given, it should be given between GL begin as well as GL end. Similar to that, I want to give some lines onto that particular object so that I should perform clipping on that particular line. I should give some lines which are not clipped. So for that, I will draw some lines here. That is nothing but GL begin lines. Check out here the difference between these two functions, GL lines and GL line loop. I should just draw a line. So I'll be using GL lines. If I want to draw a line which is in the loop form, if I want to draw a rectangle, triangle, or a square, I should use GL line loop, where it consists of some loop here. There is no breakage in the loop. So similarly, I will use GL lines so that I will draw a lines. I will draw two lines with some parameters, with some size, and then I will end that particular function there. So I got this as an input. Now I should clip this particular object. I should get the respective output which I had shown you in the starting of the slides. So we'll start the clipping of that particular line here. So I will define line function, that is line clip function there. So I'll click here, it will go to the line function. Now let's see what happens in the line clip function. Basically, from here you will start the implementation of the algorithm. I should start clipping the lines which are being displayed displayed out of the window here. So I'll define void line clip double x naught y naught x1 y1. So these are the attributes which I am giving to it. That is, I can call it as the values of that particular line here. I have defined two variables called accept as well as done. So I am giving those values as false here. By computing some points with respect to that particular functions, I should start computing each and every lines which are being drawn onto that particular object. Now I will compute some of the region codes with respect to 2 points, P1 and P2. So first I will define compute out code, which is nothing but with respect to the first values, that is x0, y0. This is, I can call x0, y0 as this, x1, y1 as this. So as I have defined some regions right in the starting part for region codes, I have defined some of the region codes. I will just assign those region codes to this particular coordinates, that is x0, y0, x1, y1. So for compute out code, so let's see what happens in compute out code. What is this compute out code? It basically computes the it basically computes the region code for a point xy using the clip rectangle bounded with respect to this diagonal, that is nothing but x min, y min, and x max, y max. I will define that function, that is int compute out code with respect to two variables x and y, which are nothing but the points here. So I will define some variable code is equals to 0, initialize it. Now I will check if that particular point is above the rectangle or not. That suppose y, I have defined line as y. I will check if y is greater than y max. I will check if so and so, the code should be equal to top. That is nothing but whatever you are defining, the line is at the top of the object or the window. If you want to check if the line is below the rectangle, I will check this condition. If y is less than y min, I will get the code as bottom. That is something but the line is below the rectangle. Or if the region code, whatever you are displaying, if it is right or left, this basically tells what region code. I have defined region code right, like 0, 0, 0, 0, 0, 0, 0, 0, 1. So I am just checking the region code for each and every object which you want to display. So similarly for right and left, I will check with the condition. If the condition is met, it will give such and such region code there. Now check here. If I take some examples for x is equals to 60, y is equals to 20 for the first point of the line, and the second code, that is nothing but second point of the line as 100 as well as 100. That is nothing but the second point. This is being just misplaced here. So I am assuming that code should be equal to 4. That is nothing but the region code here. I will get the region code with respect to this particular code, where you are applying what kind of operation? You are just applying the addition operation, that is nothing but OR operation here. So once this is done, you will get the region code of each and every point there, where you are dividing where you are dividing the particular space, the two-dimensional space of the object into 9 regions. You will get the region code with respect to this particular program, with respect to this code. Then once that is done, We'll move on to the second function called outcode 1 with respect to compute outcode x1 comma y1. We saw the first point. Now we need to check the second point for x1 and y1. Similarly, it will check for the other part also, where the function is compute outcode itself to find the region code for the second part with respect to other accesses. It will check the same. It will apply the same code for that also. So once this is done, you got the out code, that is the region code. After that, you'll check if both the endpoint region code is 0, then the line is completely inside. Just you are just performing OR operation here. If outcode is 0 or outcode 1, I'm using exclamatory mark, which basically tells if that is not true. If this is the case, the accept or done condition should be set to true, which is basically given as false. That is nothing but you'll get the function as true, where you will completely get to know the line completely lies inside the region. In this particular function, you should, as what does Cohen-Sutherland line algorithm, clip algorithm does, you are just first you'll check right where the lines are being displayed, if it is inside the region or outside the region. So this code is basically used to tell that if that particular line lies inside the region of the object region or outside the window of that particular boundary. Am I clear to all till here? Do you have any doubts till here? Students, do you have any doubts?
No, sir.
Yeah. After that, we'll check out what happens then. We saw till to check till the line or whatever the line we saw region code. If it is inside, completely inside the boundary. Well, now we should check if the endpoints or the lines, if it is outside the boundary, how to do that. We'll check out else if condition there, where outcode 0 as well as 1 code will be using this true, outcode 1 as well as 0, where you will assume done is equals to true. Or if not this case, the exception case should be at least 1 point should be outside that particular region or the rectangle. You should take that. If that particular region is outside the region, you'll check that you'll take that particular endpoint and keep that particular point there, so that you'll just get the window which you require. So this is how you'll just check. You'll just perform clipping here on this. Then what was the second case? If the points have intersection or not, you need to check that. So we'll be using slope, as I told in the morning class. The last step is to check if the point intersection is there or not, with the help of some formula. What formula we'll be using? We'll be using line equation, right? What is the line equation? Y is equals to mx plus b, as I told. Check out here, y is equals to mx plus b. So this is in the form of line equation. We'll be using for different coordinates, x and y coordinates. I have defined the formula here, where m will be the slope which you want to define in the line, and then x is nothing but differentiation in the x coordinates, that is the initial coordinates, as the find next coordinates I can set. So this is the line equations we'll be using, so that we can find the intersection point of that particular line there. Now we'll check out how to find the intersection point. If the outcode output as well as top, that is the region code top, if this is the case, as we are performing what operation here? And operation here. If the point is above the clip rectangle, that is nothing but above the clipping area. Now this formula will be the x point will be the previous point plus the initiation point, that is nothing but differentiation point x1 minus x0, into y max, the maximum of y coordinate minus the initial of y coordinates, which should be divided by the differentiation in the y coordinate. So you are just telling to check if the particular point is above the region, that is nothing but the rectangle. Once you get this, you'll assign y max value to y here. If not the case, you'll check if that particular outcode is in the bottom. You'll check. I have used this outcode with with top. If not this case, the else condition will be outcode with bottom. If it is in the bottom, you'll check if the point is below the rectangle with the help of this formula, and you'll assign the y minimum value to y here. So this is, with the help of this, you'll just check the intersection point. Then you checked for two conditions for top as well as bottom. Now you should check with right as well as left, as you will be having four parameters in the region code, right? Now you will check the right of the rectangle and left of the rectangle with respect to this, but you are just assigning maximum, that is x values to x, and x maximum value to x, x minimum value to x similarly, so that you will find out that region code for right as well as left. So this is how you will find the region code. Once this is done, now the intersection should be found, so that you will replace that particular point with respect to intersection point. If suppose outcode out is equals to outcode 0, what happens? The initial x and y coordinate should be assumed to the initial point x and y coordinate, where you will compute the outcode with respect to parameters to the outcode. Or if this not the case, you'll just take x1 is equals to x and y1 is equals to y. This basically tells the coordinate reference, where the coordinate should be placed with respect to the intersection point. So once that is done, just a second, this is done. Yeah, if that is done, if that particular this thing intersection point is being replaced with respect to that particular point, we'll check out a particular matrix where each and every object should be displayed after clipping. Now all the condition we have saw here, now we have to just draw a clipped window where the object is processed fully. First we'll check out the condition for push matrix as well as translation performance. In the push matrix, what happens? It creates a matrix where you will perform the clipping operation and then apply the translation to that particular matrix. This is just a simple code you have to remember here. After this, you'll start drawing the clipped window. These are the specifications of the clipped window, where you are drawing a loop here, a line box here after clipping, after the condition is met, and then you are defining a line inside that particular region. You are just defining here what a clipped window is, what clipped window you have got. Once this particular window which is being displayed here, which is not clipped, once you apply these operations by checking the conditions which we saw in the previous slides, once that is done, you will get an output of the clipped window here. There is some functionalities used here. Pop matrix. So what happens? Pop, you are just removing that particular matrix, whatever you have created here after translation. So this is the output of this particular program. So as I told, this is the input which we have to define. Once you perform and check all the conditions of the Cohen-Sutherland line clipping algorithm, you will get the perfect output of that particular region. So this is the program of Cohen-Sutherland line clipping algorithm.